Alright guys, here's a quick little video explanation of and hints and stuff for your homework that is going to be due at the end of class tomorrow. Sorry I'm going to be out. Please do your part and watch these videos and make sure you get your work completed that I leave for you. So, your homework check for 2 of this unit was going to be pages 10 through 13 even, and then 15 through 17 even. So, on page 10, 14 starting off, since most of these are going to be talking about centroid, you need to use the centroid property, which is 2 to 1, so that's your hint for that. 16, again, we are showing these perpendicular boxes. That tells me the distance, that's equidistant, so that's your hint on that. Once you use that property, there's not really much math necessary. Then when you get to 18, it doesn't really indicate, but they're trying to show you that XR is an angle bisector. I kind of went ahead and marked that. So is XQ. So X is really an in-center because you're dealing with angle bisectors. So to find the missing angles, which is what they want you to find, you just got to remember what bisect means, but also that the sum of a triangle equals 180. So that's your hint for there. 20. Circumcenter, that's dealing with perpendicular bisectors. The property of the circumcenter theorem basically says it's equal distance to the vertices. So they've pretty much given you y is the circumcenter, the distance to the vertice y to b is already given there for you, so that can help you for YC. And for AB, it's a perpendicular bisector, so remember the side's getting bisected, so you should be able to solve for that as well. 24 is going back to mid-segments. You'll see that on the 6 weeks exam. ST is a mid-segment. They're showing you that with the TIG marks. Okay, 2 midpoints being connected as a mid-segment. So things you need to remember, the mid-segment, you double it, equals to its parallel side, which was the PR, and ST is parallel to PR. That will help you to find the missing angles. Remember, parallel lines create certain angles, same side, interior, alternate interior, corresponding, things like that. Alright, and then to help you with 26, you might want to go back to your point of concurrency table. There's a hint to help you where see physically or know when it's going to be the same, because it's asking when will the point intersection for the medians be the same point of intersection for the altitudes, all in the same triangle. That happens only with one special type of triangle. It's just so equal throughout. That's your hint. When you get here, I think the next 2 pages is dealing with medians and centroids. Remember 2 to 1. Again, you're going to do 2 to 1 ratio all through on here. 2 to 1 again, all through here. Some problem solving on 22. You're dealing with medians. I went ahead and marked them to show you that. So your hint is to start with the fact that RV is going to be congruent to VT. That'll help you write your equation. Make sure you're setting up the equation correctly, and then solve for x and plug it back in to get WS. Because they want the measure of RW. So you need, once you have WS, since that side, it's going to be congruent to W. Alright. This is a good practice, especially if you've had problems with the last 2 problems on the test. I would do this again, because you'll see it on the 6 weeks exam. But you have to do page 15. Some things for 15. No congruent sides, that's the scaling, because they asked you to classify the triangle. 2 congruent sides is isosceles, 3 congruent sides equilateral. So you need to start off with graphing the 3 points, and then you use your distance formula and compare the lengths to determine what type of triangle it is. I think you have this. Just, distance formula. If you're not sure, if you forgot what the distance formula, basically, it's the square root of x2 minus x1, parentheses squared, plus y2 minus y1, parentheses squared. And you do that for each side. So graph your points, use your slope, rise over run if you want to make your right triangles, or use your distance formula. Now when we get to here, I'm going to do the odds here, go through the steps to solving. You're responsible for the even. So first you have to find the midpoint of each side. I went ahead and graph number 3, and I went ahead and marked the midpoints of each side. I could do that by physically see if it actually is an exact coordinate, or I can do the midpoint formula, which is basically x1 plus x2 divided by 2, and y1 plus y2 divided by 2. So either way, but I went ahead and marked that. I can see, I saw it by just looking at the slope of the side. Here, this was up 1, 2, 3, 4, 5, 6, 7, 8. and then over 4, so I just did half. It's 4 and 2. And so this is midpoint. Now, the midpoint on this example that I have here for the side, or M, I'm using side, the midpoint. This was 1, 1, and then the midpoint X, which was the other side, which was 5, 3, I believe, yep. And then Y was 3, negative 1. And to find the centroid is the only one that has a formula. And the formula is just add up your x's, x1 plus x2 plus x3. I know that kind of doesn't look like it. This is a 3. And divide by 2. You're taking the average of your midpoints. So, trying to fix this, x1 plus x2 plus x3. Divide by 2. And I just took these numbers. These are all my x's. Add them up. That's 8, 9. So this is 9 over 2. And then add up all my y's. Sorry. Add up all my y's here. That's going to be 2 and 1. Right? Yeah. So that would be 3 over 2. Okay, so just add up. Find your midpoints first, then use your centroid formula. You can get fractions or decimals. Then for your altitudes, you need to find the slope of the side. So I'm going to go ahead and just start. I did number 5 and went ahead and graphed it. I know that this side right here is horizontal. So it's perpendicular slope, which is the opposite. Reciprocal is going to be vertical. And the altitude basically is from a point to the opposite side and it's perpendicular. So I can physically just go ahead and draw that one and see that that's my altitude going from that vertex to the opposite side. But then I need to do another side because I have to do at least 2 because I have to find the intersection in order to identify my orthocenter. So I want to find, let's say I find the slope of this side here. So this is a rise up. 1, 2, 3, 4, and then to the left 2, so that's a negative 2. So let's just say the slope is negative 2, oh sorry, negative 4 over negative 2. Which is a negative 2. Then I do the perpendicular slope, which is 1/2. Now to do that, I have to start at the opposite vertex. The opposite vertex would be over here at the negative 2, 0. And now I'm going to do or complete a slope of 1/2. So that means I'm going to go up 1 over 2 plus that point, up 1 over 2. And then I can see it intersects exactly at that point. And you want the point of intersection to get the orthocenter. So this orthocenter on the example that I did is at 2, 2. That's where they meet. And so you're going to have to graph the point, find the slope of the side, then find the perpendicular slope, then start at the opposite vertex using the perpendicular slope to plot additional points. You have to repeat that. You got to do it twice to find the intersections of the special segment. Now, for perpendicular, oh, and I forgot. So let's say you're having struggles with these type of problems. These are the notes that you should be using. It was the video that I did that I checked that you completed, and they had the steps here. So if you're not too sure, use those notes, find those notes to help you with these type of problems. Alright, so on the last section here, or the next section, excuse me, you're doing perpendicular bisector. So when I'm dealing with perpendicular bisector, I first need to find the midpoint. I'm supposed to have this right here. Okay? Of each side, or start with the side. Then I need to find the slope of the side. Then I need to find its perpendicular slope. Okay, and use the perpendicular slope to, and I'm going to start at midpoint and use perpendicular slope to graph additional points. To graph the line. Alright, so in the example here that they gave me, I can physically see where my midpoint is. Like if I start there, I see the midpoint, it's negative 1, 1. Then I need to find the slope of this side. I believe it's the same one as before, it was 4 over 2. So the slope is 2, and then the perpendicular slope is a -1/2. So I'm just literally going to go down 1 and then to the right 2. And I can see that's going to be my perpendicular bisector. Then I want to do that for an additional side because I have to find the intersection of the perpendicular bisectors. I don't need all 3, I just need at least 2. So I can see this is the midpoint of this side. I want to find, I probably should do a different color. Alright, so this is the midpoint right here. I want to find the slope of this side. So the slope, if I look, I'm going down 2 and then to the right 4. So the slope is a -1/2. So the perpendicular slope, is 2. Now, it's just coincidence that this happened. They're the same. This is not going to always be the same for each side. So, but basically, I'm going to go up 2 over 1, and I can see right there. Oops, that's not exact, but what you have here is right there is your intersection, and that would be the circumcenter. So our circumcenter here would be 1, 0. Okay, so you need to do those steps for number 8. And then when you get to number 10, because they want you to show that the mid segments are parallel and half the length of its side, to check for parallel, you need to check the slopes. And then you also need to use the distance formula to check the lengths to determine its half its side. Now, basically draw your triangle, find its midpoints, or create 2 sides where midpoints. I'm going to go ahead and just do these 2 because I can physically see that's exactly a midpoint. So, and I did that one because it's easy for me to count horizontal and vertical lines. It just happened to work that way. But I know that my green line is my mid segment. I can physically see these 2, both lines are horizontal, so I know that they're parallel. So that's proving that they have the same slope. They're both horizontal. They would have the same slope. And then I could, if I needed to, I could just, what happened? Oh. So I could count, this unit right here is 2. And then if I count here, 1, 2, 3, there's 4. So I can physically see that it's half the length of the side. Okay? So you are responsible for that. Now, this is all the old material. New material, your notes that I'm going to check for on Friday. You had formulas on your graphic organizer. I'm going to give you the formulas you need for each set of problems. And you will need to memorize these formulas. So if I'm talking about total degrees or talking about sum of the interior, you use the formula n minus 2 times 180. And n is your number of sides. Okay? Now, you're just plugging it in. So like if I'm doing a 24 gon, I'm going to say 24 minus 2, then times that 180. And that will be 3,960. So that's what you're doing for this set. Because they want you to find one interior angle of a regular polygon, well, if I want to find one, I use the sum of the interior, which is be n minus 2 times 180. And if I want to find just one, now I'm just going to divide it by n. So that's the formula for this set, 5 through 8, or 6 and 8, which you're responsible. To find one exterior angle in your graphic organizer, each exterior angle formula is 360 divided by n. So you're going to use that formula. N is your number of sides. So I'm talking about a dodecagon. This would be 360 divided by 12. And then here also they're asking, for you to determine the number of sides. So there's 2 ways you can do that. We're going to work backwards. If 360 divided by n gives me the degrees of the exterior angle, of one exterior angle, then if I do 360 divided by the exterior angle, that would give me the number of sides. Or if they don't give me the exterior angle, if I want to find the interior angle, well, that's just 180 minus the exterior. So, or 180 minus the interior. So I could also do 360 over 180 minus the interior angle. Because if I do 180 minus the interior angle, that would give me the exterior angle. Okay. So here's your formula here. And then here, whenever you have algebra expressions in the interior, You're always going to find the sum of the interior angles, and that's using that formula n minus 2 times 180. So you first do that. So if I was doing 17, this had 1, 2, 3, 4, 5, 6 sides, so 6 minus 2 times 180. This ends up with the interior of 720. So you first find the interior. Then second, you're going to write an equation using, write and solve an equation. I'm going to abbreviate that. Using the sum of the interior. So, for example, I would add up my variables, add up my constants, my numbers. This equation for number 17 would end up being 2n plus, when I add up all these numbers here, this would be 494 equals 720, because that was the sum of the interior. The equation is always going to equal to your sum of the interior. So to help you out on 18, make sure you're starting off with n minus 2 times 180. N is your number of sides or number of angles. You can look at it that way. And of course, to get some additional practice, go on to the next part. These type of problems you're going to see on your assignment for Friday. I hope this helps. Make sure you turn it in at the end of the class period. Like I said, I'm going to come by and pick it up. If you have any concerns or questions, just post me a question on Emoto. I'll get the alerts on my phone, and I'll respond or come over if I need to. All right, thanks.